So we're looking at a very complicated piecewise function. Don't worry about the pieces of the piecewise function. I'm not going to make you graph it. What I'm going to make you do is identify the different transformations. And we're going to really focus on how the ordered pairs are being transposed. And not necessarily just visually looking at it. Because some of these, yes, it's easy to tell. Oh, it's been shifted down. Yes, easy. But pre-calc questions aren't usually that simple. So here's your original function. For my slides, I have the original compared to all the new ones like side by side, so it's a little easier for me to compare the two. You guys are going to do a lot of flipping. So maybe look up at the board as we work. But what from you, here's what I need. I need to know what we can call this transformation. And it's done in function notation because no one wants to write that piecewise function over and over and over and over again. So, Daniel, do you remember when I throw a 2 in front of a function like this, what it does to that function? Okay, take a wild guess. Yes, you're just having a hard time figuring out what that's called? It's a stretch in the vertical direction. Very good. This is a vertical stretch of 2. So what that means for us is it's going to take all of your y values, your vertical components, and it's going to stretch them by a factor of 2. Okay, my favorite ordered pair on this whole function is this guy right here. Can you guys get your bifocals out and tell me where that ordered pair is, this little peak?
3, 4.
Yeah, I'm thinking it's at 3, 4. So for many of these transformations, I'm going to keep referring to my buddy 3, 4. So if I took that ordered pair 3, 4, Daniel, and you vertically stretched it by a factor of 2, that means you'd multiply your y value by 2. So what y value am I looking for that guy? It's going to become the ordered pair 3, 8. So what I need you to do, Daniel, is flip through your choices and see if you can find one where that little guy all of a sudden becomes a 3, 8. Yeah, I'm with you. So, boom, right there. First one. Nice job. Yeah. Kira, talk to me about the next transformation. Be inspired by Daniel. What if I throw a 3 in front? What does that do? Still a vertical stretch of, no, this time it's a 3. So if I go back to my old buddy, 3, 4, and you vertically stretch it by 3 this time, what's the ordered pair that I'm looking for this time? 3, comma, and then multiply that 4 by a 3, 12? Okay. So get your eagle eyes out and go look through all of your options except for A, because that one's done. There's more in the back. Keep flipping. Don't judge. Now, you're having a tough time finding it, Kira? Because I did an old math teacher trick. Well, I didn't. Mr. George Johnson did. It's not even there. There's more choices than there are options. So this is one of those cases where it's not there. Now, you guys are smart about this. If you do a little count now, you realize there's only one more on here that's going to be the extra one. It's not until the end, so you'll be okay. All right, so from here on out, I'm not going to trick you like I did Kira. Sorry, Kira. Let's talk about this next one. There are 2 transformations applied to this. Oh my goodness, Cheyenne, can you tell me what 2 transformations are there? A vertical, you can call it a stretch. Can we call it a compression, though? Compression of half. What else? When I throw a negative in front of it like that? So, do you remember what that's called when you... Just flip it through our notes. Poor guy. I know you want to call it a flip, but we're not calling it flips anymore. We're calling it a... A reflection in what direction? Because now that we're pre-calc, we have multiple kinds of reflections. It's reflecting over the x-axis. You tell me, where would the negative show up if it was reflected the other way? Inside of the f of x. Very good. This one doesn't do that, so it's a reflection over the x-axis. It's a vertical reflection, some people call it. All right, let's go back to my old buddy, 3, 4. Cheyenne, if I did those 2 transformations, which technically can occur at the same time or in any order because they're not really going to change each other, your y value is going to get cut by half, and then you're going to reflect it to the opposite. So opposite sign. So you can reflect it first if you want. Now you're down here at -4, and then if you compress it by half, where are you going to be now? -2 for the y value. Very good. So a reflection's pretty easy to see when you guys are looking through your choices. All right, girl, start scanning. I'm specifically looking for something that's been reflected, and it goes through. Oh, and it's B. Look at that. That would just be really awesome, but they're not going to go in order. Just trying to. I think he did that on purpose too. This is so weird.
No,
Adam.
I think I have anxiety.
This worksheet gave you anxiety.
I don't know. I have it right now for no reason.
It's game day. Pumped up.
No.
No.
Usually
Coach,
I'm
don't
absolutely
listen.
by this time.
Adam, what transformation occurred in this function notation here? Left 7. All right. So for me, I'm going to go back to old trusty 3, 4. If you shifted that to the left 7, that wouldn't change your x value, but what would your y value? No, it would, Abruzzo. What are you doing? Oh my gosh. Ignore everything I just said. It would totally change your x value. Because if you're going left 7, where are you now? So you would subtract 7. So you'll be at negative 4. The height is the thing that doesn't change. I was really confused for a minute. All right. Have you found the graph that moves that little guy over to negative 4, 4? Well, let me catch up to you all. Okay, this one? I like that. Good. Just with that attitude, Cameron, you're going to do the next one.
Well, I mean, I can do this. It's just
You
my
got
anxiety's kicking right now. So
You know, nothing soothes your anxiety like a nice matching worksheet in math. Ready? Let's work through this. What about when you throw a 2 inside of the function? This is not going to be the same as Daniel's problem where he had a vertical stretch because he was outside of the function. Now it's inside.
horizontal stretch.
Okay, it is horizontal. And with it being inside of the function, everything's backwards. So this 2 is actually going to be a horizontal compression. So what you call it after this point, I don't really care, because some kids are like a compression of 2 and they know what that means, and some kids say it's a compression of half and they know what that means. The idea is, can you find the match? So most people, Cameron, say horizontal compression of half. Here's what I look for when I look for a horizontal compression. I mean, I don't know. I haven't even looked yet. Right? I mean, you can take our old trusty 0.34 and you can horizontally compress it by half, but that means you're going to be looking for 1.5, and I don't think my old lady eyes can see that. Here's what I'm going to look for. All of your x-intercepts are going to be pulled in by a factor of half. So let's go with this one. That looks easy to halvesies. Look for the one that has an x-intercept. Instead of at negative 10, you're looking for something at negative 5 instead. Did you find it?
Yeah, it's G.
Hold on. I gotta confirm. I totally confirm. Now, did you notice, Cameron, your heights of all these little peaks and valleys, none of those changed.
Yeah.
So he's just as tall as he was in the original. But the horizontal compression is going to be noticed on the x-intercepts. So I already forgot what this was. Was it f of 2x? There we go. Thank you, Cameron. Did that help? Aren't you feeling real nice and calm now?
Not really.
Oh, maybe you need to do another. This whole worksheet? Oh, we're doing them. Just in general, life. You know, maybe.
But again, I always don't have breakfast.
Maybe it's a combination of events. You want to eat some of Mrs. Hoffbauer's candy? You want the absolute value one? That is my favorite. Sure. You're having a debate? This one or the other one? There's 3 of them. The first one? Boom, boom, boom. Yep. All right.
Absolute value one, that's E.
Okay. So, Taylor, what are you thinking about the absolute value of f of x?
Well, it's got to be positive.
Yes.
Everything's got to become positive.
So all the y values have to be positive. Because if you take the absolute value of your function. So it's going to take your weird little function, whatever it looks like, and it's going to take all your negative y values, and it's going to reflect them up to the, wow, that was aggressive. You need to reflect them up to the positive land. So did you find your match?
It's C.
It is C. Now don't hurt Piper.
Never mind, I'll move on. Wait, how?
I was also wrong, Cameron.
So if you took all of your negative outputs and you took the absolute value of them, it would take all of these y values and reflect them up here.
But why didn't it reflect in the little hump?
It was already positive. Yes, it would only take, because if you think about absolute value of 3, you don't change that, right? Absolute value is the distance from 0. So in our case, all these negative dangling pieces get reflected up to the positive region. Okay, good question. All right, shall we back up to the one before that, though?
What's E?
I don't know. We'll get there. All right. Aiden, can you walk me through this one here, f of x over 2? And what if I rewrite it like this? That way other people can look at it and maybe understand what's really happening. Does that help you identify the transformation there? Very nice. This is a horizontal stretch because it's backwards and weird. So you can call it whatever you want from this point on, but technically a horizontal stretch of 2 is what most people tell me because it's opposite. So let's go back to that same kind of transformation that Cameron was doing. It's going to take all your x-intercepts, and this time it's going to double them, so they're going to go twice as far out. So this negative, what does that say? Negative 10 needs to be out here at negative 20. Can you find one that does that? Aiden? Yeah, probably. You sounded really confident. I'm with you. That works. Thank you. All right, back to absolute value land.
Yum.
Okay. Taylor, you want to tackle this one too?
Yeah.
Okay, do you remember what happens when you throw an absolute value inside of your function? This is a very weird transformation.
Let's do the opposite.
Okay. Well, it kind of does. So absolute value of f of just the x. Okay, so here's what it's going to do. It's going to pretend like it doesn't even acknowledge the negative part. So it's going to erase the left-hand side of your function. It's going to pretend like your negative x's aren't even a thing. And then it's going to copy the right side and paste it over to the left side. So be careful. You need to find the function that erases the left side.
E. E.
You're debating E and F.
I
I believe it's E.
It is E, yes.
So then basically like, so the absolute value of
Yes. It pretends none of this exists because it's like there is no such thing as a negative x.
flips it over because it's the reverse.
It still needs outputs, so it gives you that back again. Yes. Isn't that strange?
So it's like kind of backwards.
Mm-hmm. So like over here, it might have x equals negative 5 originally in its input, but the function is going to force it to be a positive 5, and then it's going to give you that same output again that it originally had on the positive side. It's very
so
weird.
What is F?
I don't know. Let's look at the next function.
Is it negative? Is it negative F?
Yeah.
Ah, ooh, look at that guy. Okay, so what does that mean?
When I erase this in right side.
Yes,
Okay, so
that
there's
was a good math joke. I liked it. Input, get it? All right, negative x inside, what does that mean?
the absolute value of so then it becomes positive.
Okay, you're thinking algebraically, kind of, yes. This is one of those cases where transformations matter in what order you apply them. If you didn't have the absolute value bars, if you just had f of negative x, what transformation is that? It is a reflection over the y-axis. So think about doing that first. So go back to your original. Spoiler alert, it's got to be f, because that's the only other one, okay? Think about if you reflected it over the y-axis. So this dude would end up over here on the right side now. So then, when you apply the absolute value to the reflected version of it, it would actually erase this side, which is now on the left side. I can't draw that, so I'm not going to bother. And then it pastes that side. So that's why this one is f of absolute value of x. Guys, I promise I will not do that to you on a test. That is nasty.
I'd actually prefer that.
You like that one?
Yeah, I like that one too.
All right. Well, I'm super sorry. I'll write up a new question for you, I guess. You might see the f of absolute value of x. So this one here, where you just have to know to erase the negative side and paste over the positive side again. You might see that. But not with an additional transformation on top of it. That's too much. All right. Oh, we're almost there. Okay, I'm really worried about this one. Because there's two transformations, and even more particular about the two transformations, the order in which you apply them makes a huge difference. So, who thinks they can tell me which one of these transformations must be talked about first? The reflection or the down? The reflection has to be done first.
Can you go in like order of like not
Yes.
operations, but like from like
Yes, with the exception of if there's existing parentheses. So if it was like negative quantity, you have to know to distribute it. So if you ever run into that, Taylor, I say just distribute it and then go in order. That's what I do. Dyslexia, man. Yeah.
Why do you have to do this when it's not good?
Okay, so if you were to apply the downshift to your function first, so that would be like f of x minus 9, right? And then if you came back after that fact and said, now I want you to reflect everything, you'd do this. And what happens with this down 9 shift? It becomes a plus 9. I'm going to show you, when we get to the graph, Daniel, I'll show you exactly what I'm talking about with an ordered pair. Let's go back to our old faithful. 3, 4. Let's talk about them. If we apply those two transformations in that exact order, okay? So starting with a reflection, which part of the ordered pair is going to change if I reflect over the x-axis? This way. Yes, so the 4 becomes a negative, whoops, right here, a negative 4. And then if I come back through and I say, now I want you to shift everything down 9, who changes now? The negative 4 changes to a negative 13. So first thing I want you to do, go through your options, go find me a function out there where this little hump, this maximum, is now down here as a minimum down at negative 13, at 3, negative 13. Is I? Hold on, I gotta catch up to you. Agree. All right, Danielle, let's talk about that. What if we didn't go in that order? So what if we took our old buddy 3, 4, which I can't see anymore, but let's pretend it's right here. What if we shifted everything down 9 first? So this would become 3, negative 5, like here. And then when you reflect it, it ends up here.
Yeah.
Totally different function. Yep.
I
Get it now? Okay. Okay, we're down to the final 2. One of them is bogus, not going to be used. And I think the only one left is... Did we not use J yet? So, question for you. Is J been shifted this away or this away? The only difference is this versus this. What's the difference, guys? X minus 5 versus x plus 5. Translate that for me. Which one's left?
The right one is left.
Alright. This one says left 5 and this one says right 5. Here's your new guy. Just take a step back and look at it. Does it look like it was shifted left or right?
Middle.
So this is the function f of x minus 5 minus 6. Ooh. That was a fun time. How's your anxiety doing now? Feeling good? Didn't help? Dang. Maybe after the lesson. We're going to do some nice, soothing writing equations.
I just need to listen to the sounds of the ocean
Okay.
and the jungle in the background.
I mean, maybe. You know, I've been told by many students that watching my videos calms them right down to the point of sleep. That wasn't a compliment to me. You know when I can't sleep, Mrs. Abruzzo? I just watch your video. Great.
Hey, math is the last thing on their mind before they go to bed.
But then you'll dream about math.
Pretty good. But you know that's like a proven way to get good at something. Right?
Yeah, like hypnosis kind of, you
And then
know.
go to bed.
I'm with you. Maybe.
So,
Try it.
for
You'll
real,
have nightmares about me yelling at you about transformations in their correct order or something. So you guys are on worksheet 8B right now. This lesson is just a one side of a worksheet, but it will take us to the end of class, so let's get going. This is another antique worksheet. It's a good one. We couldn't get rid of it.
She's a beauty.
So I wrote a big note on your homework that I posted today in Google Classroom. I wrote a note about make sure you show work. What we're about to do, every single question is going to have work. And if you just show me an answer for every single question on worksheet 10, your assignment, I'm going to be very suspicious of your integrity. Okay? These have work. Let's start with equation number 1. Your first task is to identify, first of all, the parent function here. Can you guys give me a name for what this is? That's a parabola. So here's what I need from you.
Are we? I'm right.
HB.
That's my issue.
You're like, no, you're wrong.
I don't know where we are. I'm so
HB. HB. Back up. Back up. One half page.
Yeah, I was on that page.
10's your homework assignment. I'm sorry about that. Just the evens, though. All right, so your parabola, which, yes, it is a parabola, the parent function is y equals x squared. But because this one clearly has some transformations that occurred to it, I need the transformation form of a parabola, so I need vertex form. The good news is transformational form and all of your functions pretty much look the same. You throw an a in front of the body, which for a parabola would be x minus h squared, and then plus k. So every time I ask you for a transformational form, you're going to have to really think deeply about who's the parent function. Is it a quadratic, a cubic, a square root, absolute value, what's going on? You have to identify two things for me. You have to identify the vertex, and then you need to use a particular ordered pair off of the vertex somewhere. We actually had this question on your test last week. Remember this? Where you had to do a little work to find A? Some of you were like, yes, and I got it wrong. So here is your moment to make it better. All right. Who am I talking to? Sky, you see your vertex out there? Yeah, it's this guy. What ordered pair is that at? And remember, this is dot paper, so you got to count the dots instead of looking for coordinates. Is it negative 3, 0? Yeah, I'm with you. So Sky just found our h and our k. From here, we need to use an ordered pair, and the original person who wrote the worksheet, they went ahead and gave you an ordered pair to use. So let's trust their judgment, because what we found in first hour was we were really certain that there was an ordered pair that we liked. Turns out it was not that ordered pair. So on a test, I will clearly label ordered pairs that I would like you to choose from, and you choose your favorite, okay? So Sky, we're going to use this ordered pair right here. And this is your random x and y value for input and output. If Sky plugs these into the general formula that we just came up with in the correct place, we're going to be able to solve for A. You can use any ordered pair, but like I said, in first hour, we learned a valuable lesson that this worksheet, with it being so old, it's a little hard to see some of the ordered pairs. Like this one, for instance, a lot of kids thought that was 0, 2, and maybe it's not. Maybe it's really like 0, 1.9 something, and we don't know that because it's not labeled. So if they label something, please use it. All right. So, Miss Sky, from your random ordered pair that we are forced to use, what was the y value? It is 1/5. Good. And then we're not going to know a until we do a little math. But everything else I can write down. All right. Who is the x value from that ordered pair? I'm asking Sky. Sky, who is your h value you identified from your vertex? So I'm going to do a little plus minus thing. I'm going to make that a +3. And then k value? Nice. So what I would encourage you guys to do is simplify this. Just be careful about it. I usually like to look at this weird piece of the function and simplify this part first. Miss Sky, -2 + 3 is boring because it's a 1. And then you're going to square a 1, and that's still boring. So Sky has a very boring list of math to do for me. She can't subtract anything because it's 0. She can't divide by anything because it's 1. Sky, your a value is 1/5. So now she's finally ready to write her equation down. So y equals, she just found the a value to be a 1/5. She's going to leave x and y as variables, but she is going to plug in her h and k because that's going to be standard for all of the parabola. So what is your vertex at again? So +3 that'll turn into, and then do I have to put a +0 here? No, could I? Yeah, we'll do that though. All right. So that's your standard parabola question, and that's how you guys were supposed to do the second question on your test last week. But today, we're better than that. We're going to see other functions besides just little parabolas. Yes, Kim? What? Oh gosh, this is such a generational gap. Okay, so when I was in high school, we had block scheduling, which meant you went to 4 classes a day, and then you switched your schedule at the semester, which sounds great, right? Except you had 90-minute classes, and then you had lots of homework. So you're supposed to go home and work on PreCalc homework for an hour every day.
What time did you get out?
Oh, it was beautiful. We started school at 7:15 one year, and then we got out at 2:02.
Oh, that's fantastic.
2:02.
202.
Think of the possibilities, guys. All right.
You have to get up at like 5:30.
Who wants an easy question? Nobody? Okay, Taylor. Number 2. It's just a line. We don't have to do a lot of work here. Can you give me the general form of a line?
So what's my block right now? I really want to fill it out.
I guess you would be in the middle of block 1, 1.7. All right, so Taylor, if you can tell me your slope and your y-intercept, that'd be beautiful. Now, another valuable lesson we learned in first hour. We thought we knew the slope, and kids were looking over here thinking they knew what the point was. Turns out that's not a good point to look at. So what I might suggest you do, Taylor, is look at your what we know is the y-intercept, and then check out this point. Count for slope using those 2 points. It's a little more secure. We're going to get the right slope this time.
Well, we have a slope of 1, 2, 3, 5 over 2.
So down 5 and over to the right 2. So slope of -5/2. Yeah. And then your y-intercept, I think we kind of stumbled on when we circled that point. Where was your y-intercept? I think that's at 6. Get your bifocals out. All right, so your equation is y equals -5, whoops, halves x, that's, I don't know what happened there, plus 6. So in the case of a line, you're right. I'm not going to see a lot of work because you guys are just going to do a little counting to figure out slope, rate of change, and y-intercept. Also might be true for equation number 3 because an absolute value function inherently is a linear function. It just has some weird reflections going on. So let's talk, and I'm going to make you do this the long way anyways just for the sake of practice, so apologies in advance. Jasmine, you're going to help me walk through this one. First of all, number 3, are you okay with me calling that an absolute value function? Okay. Do you know then what I could write as a general transformational version of an absolute value function using the a and the h and the k? Any thought of what that looks like? Okay, so it starts off the same as, I forgot who helped me. Who helped me on the parabola? Oh, Sky, yes. So Sky, remember, started with an a. And then her body of her function was quadratic, so it was x minus h squared. Yours is an absolute value. So you're going to say absolute value of x minus h. And then do you remember what the end piece looks like for the general form? It's plus, and we call it a k. Very weird. So Jasmine, what I need from you, you have to identify the vertex location for your absolute value. And then we're going to have to use one other ordered pair. You take the absolute value of it. We'll get to that. All right, where's your vertex located at, Jasmine? Have you found that? Thank you. So that is the h and the k she's going to use in her formula. Now, technically, if you guys were really savvy about absolute value functions, you could count and tell me what the a value is because it is inherently a slope question. But humor me, and let's do this the old-fashioned way by finding another point, Jasmine. Which other ordered pair do you want to use? I think that's a great point to use. So that is a random xy ordered pair that we can utilize. So using the values that she just selected for me, the y value from that point was a 1. I don't know a. The x value from that point was a 6. Jasmine, what's your h? I think it's positive 5, but so there's a negative in the formula. Is that what you were telling me? Okay, I gotcha. Close the absolute value bar, and then you're supposed to add the k value. What's the k value? Awesome. So Taylor and I were having a short side discussion here. She's like, what do we do with this? Well, you're just going to compute it. So Jasmine, 6 minus 5, better known as 1, and when you take the absolute value of 1, that's boring. You get 1. I'm very sorry. I really need to give you guys something more challenging, I suppose. All right, so Jasmine, you're going to subtract 4, and then I guess you're done. So you just found out that your a value is -3. My friends who are using the old count the slope idea for this only works for lines and absolute values. If you were noticing, the branch went down 3 and then right and left 1. That was another way of identifying a. So Jasmine, we're finally ready to fill in everything we need to know about the formula. What was our a again? -3, and then absolute value of x minus who's h? Good. Close the absolute value, and then who's k? Awesome. Nice job. That wasn't too bad. We got this. Ooh, look at 4. What'd you call these yesterday? Swoopy squiggles? It's not a swoopy swiggle at all. Alright, man.
I just know that one is square root function.
Number 5? That is? You're right. You're my go-to guy on number 5. Riley, you want number 4? You got this. Now, besides a swoopy swiggle, any idea what the name is of this number 4 function? It's a cubic. Very good. So it looks a lot like Sky's quadratic and a little bit like Jasmine's absolute value, but your function's body is going to be raised to the 3rd power. So the general form still starts with an A. It still has an x minus h, but this is where you're going to get a different function. You have to the 3rd power, and then plus k. All right. So you don't have a vertex, but you have a center point where all the wiggles center from. Can you identify that center point for me? I think that makes sense for -2. So she just found her h and her k. And then I need you to use another ordered pair that you are pretty darn sure of the location. Call that 5, -1, and I'll agree. So she's going with the ordered pair 5, -1. That is going to be a random xy ordered pair that she can plug into the appropriate places. This will allow her to solve for a. So the y value is -1. Riley, you don't know a yet. We'll just leave that like a variable. Who's your x value from your ordered pair? Good. And then we're supposed to subtract the h. Who's your h? Good. And then that thing is cubed, and then we have a plus k. That would be weird to say plus -2. Do you mind if I just write -2? Okay. All right, time to simplify. I always suggest you guys work with this piece first. So Riley, oh, yours is boring too. I'm so sorry. 5 minus 4. 1. 1 to the 3rd power. Still 1. So -1 equals a times 1. That's boring. -2. One step and you got it. What did you just find for your a value? My gosh, that is horribly boring, Riley. I'm so sorry. All right, a is 1. So I know what you're going to say. Abruzzo, I could totally tell that was a 1 before you even did your math. Nope. Nope, you can't. Okay? So you need to do the math. All right, Riley, we're going to write our equation now. Can I put the 1? Do I have to put the 1? I can leave it off, I suppose. All right, so x minus, your h was a 4, wasn't it? This is the part kids always forget. Because she is a cubic, make sure the body here is cubed. And then -2, or if you wrote plus -2, I wouldn't count you wrong. That's just real weird. Someone else might make fun of you, not me. Cameron, it's 5. You ready? So you told me this was a square root function. I agree with that. Can you write the full transformational form for it with the a and the h and the k?
Square root.
Before the square root, though?
A.
Yeah. Square root. Keep going.
X minus h.
Very nice.
Plus
Very good. So, guys, the only thing that we've changed between Sky, Riley, Cameron, and Jasmine's absolute value was this. In the previous question, Riley's was this. And in Sky's question, it was squared. So you just have to concentrate on, okay, here's my function's basis, is in Cameron's case, is a square root function. All right, again, it's not called a vertex, but the beginning point where your square root function originates, where is that? I know, get bifocals out, man.
-8, -6.
I agree. Which doesn't mean anything, but I agree. All right, so this is your h and your k, and this is the problem first hour. We got into trouble because a wonderful young lady said, well, I'm going to use the ordered pair 5, -5, comma 1. And I was like, that's beautiful. I totally agree with you. And you know what happened? Disaster. It is not at -5, 1. And we only know that because we tried it, and it turned out real funky. So here's what I'm going to tell you, so we can avoid that. Cameron, can I just tell you to use this ordered pair?
Yeah.
And it's going to be exactly where you think it is, which I just can't see what it is. Is it -7, -2?
Three.
-2, isn't it?
Yeah,
2. Get your bifocals on and count. I don't know. It might be 3.
It looks, no, it's, I
Is it?
think
It's the dots. I know
Yeah,
what's
the
confusing
dot.
you guys. You've never seen dot paper
The
before.
dot and 6 look like there was a point.
Such generational gap. Oh man. All right. So the y value from that ordered pair. Well, this is boring. Both x and y are -2. So -2. We don't know a yet, Cameron. The x also was -2. Who's your h again?
8.
-8. So when I do a subtract -8, I'm going to do one of these. Yep. Wait. Something's wrong.
What's wrong?
That's a 7. Why are you letting me do this?
Oh, it is 7.
I can't read my own handwriting.
Yeah.
-5, +1. Which seems really appropriate, right?
I thought you said -5.
Oh, that would have been the
And I was
problem.
like-
Yeah, Cheyenne's like, well, it's
Because
not.
she used the point from pot 6.
No. I don't know what's wrong with what. Nothing that she did was wrong. It was a me problem. Okay, so plus k. What's our k value? I don't know. I'm afraid to even write anything down. -6. Okay, great. All right, let's solve. Cameron, talk to me about this component of the function. -7 + 8, better known as square root of 1, better known as 1. There we go. So boring again. I apologize. You have -2 equals a times what apparently is 1 now -6. P.S. in the last class we got 3 squared to 7 over 7. Oh no, I'm sorry. 3 squared to 6 over. It was bad. All right, so we're gonna solve. Cameron, you just got one step and you're done. Yes.
So whenever we solve for like whatever is in parentheses,
Yes.
square root, is it always gonna be 1?
No, but they sure do make it seem like that, right? Not always 1. In your homework, you're going to see some weird things pop up, okay? So you just found an a value of 4, Cameron. Let's plug in everything we know for the formula. Y equals, throw a 4 there. X plus 8, good. -6, beautiful. Oh my gosh, guys, we're going to run out of time. I won't even get to do my favorite one. Just real quick, who knows what this function is? Swoopy squiggle. It is a cube root.
Oh.
Oh.
Oh, guess what, Taylor? The a value is I think it's a negative. Oh, no, it's not. I think it's -2 this time. I don't know. It comes out fairly nice is my point. If you wanted to see it, I did post it on the slides. But guys, here's the thing. Every problem you start for your homework should start with that step right there. The general transformational form written down. Go find your points. Plug them all in. Okay? Good luck. Your homework is the evens on worksheet 10. Make sure you show work. The only exception to that would be if it's a line. Then I will accept that you didn't have work. But other than that, you got work.
Really good at